and look at graphing relationships to see if they're proportional. So remember, I said yesterday that another way that we can see if something is proportional, we said find the unit rates, look at the ratios to see if they're constant. Today we're going to be graphing them, and there's one criteria, that's our third way to see if something is proportional, and that's what we're going to look at today. So before we get started with that though, there's a couple words that, and all three of these terms are very important with what we're going to be doing today. The first one, linear relationships, that is something that you're going to be using and seeing the rest of the school year, and even into 8th grade, 9th grade, 10th grade. So that's a term that you're going to hear and see quite a bit in the future. They're graded, I just need to put them on the computer. Okay, so looking at the word linear, this is a linear relationship. What word in the word linear basically tells you what it means? Line. A linear relationship, when you graph it, it forms a straight line. So it's not going to be a straight line like this. It'll usually be like a diagonal line. That's what we're going to be looking for. So not this, one like this. So if it forms a straight line, as opposed to something like that, or a curved line, those are not linear. This is linear. Okay. Independent and dependent variables. So you all talk about independent and dependent variable like in science projects. Usually is where you've seen them. In a graph, that's when we have independent and dependent variables as well. Independent. What does it mean to be independent? Do it on your own. The independent variable does not depend on the other. You can, in other words, think about it as you can change it. For instance, if you make $12 an hour, okay, as they say you make $12 an hour, can you decide how much money you make every hour or how many hours you work? Hours is the independent variable because I can decide or change how many hours that I work. I can't change that I get $12 an hour. That's already given to me. So independent variable, it's the one that doesn't depend on the other. It's the one that, in other words, you can change. That's one good way to think about it today. The dependent variable, it depends. So how much money I get, doesn't that depend on how many hours I work? So that's why it's a dependent variable. A lot of times, money and cost is the dependent variable. Almost always, money and cost. Independent variable would be like number of pounds or ounces, number of hours. Miles is usually dependent, hours or seconds is usually independent. Okay, so that might help us as we make our graphs later today. So when graphing these proportional relationships, this bullet point right here, this is the important guy. If a graph makes a straight line and it goes through the origin, it's proportional. So we've talked about, at this point, before today, two ways to say if something is proportional. The unit rates are the same, or constant ratios. The third way that we can say something is proportional is if you graph it and you get a straight line that goes through the origin, or the point 0, 0. That's the third way that we can say if something is proportional. And I will guarantee you are going to see questions in the future that say, what are the three ways to say that something is proportional? And you need to remember, same unit rates, constant ratio, the graph makes a straight line that goes through the origin. So those are the three ways we can say something is proportional. Constant ratios, straight line through the origin, and same unit rates. Okay, so when graphing these relationships, the independent variable is x. It goes on the x-axis. The dependent variable goes on the y-axis. And that also helps whenever we have to see what coordinates each point gets. Independent is x, dependent is y. So a lot of times if they're not given to us, we'll make a table with our points and say this is x and this is y. Graph those points, and then we're going to connect each point to see if the line is straight and if it goes through the origin. And a lot of times, so it's not given to us today because I want us to get practice with it, but a lot of times the x and y axis will already be labeled for us. We don't have to decide which one is which. We've just got to go and put the points in the right spot. But I sometimes it's not going to, so I want to get practice with labeling the x and y axis. Now, the graphs on your papers, aren't showing up very well, so we'll do our best with this. Once we do the problems later on today, it'll be a lot easier. The graphs are pretty easy to see. So this one, the slowest mammal on Earth is, believe it or not, it's not a jay. It's actually a tree sloth. But it moves at a speed of 6 feet per minute. So we're going to see if this is proportional or not. A good one, right? Yeah. All right, so the first thing we're going to do is decide what are the two units that we're looking at. Vincent?
6 feet and minute.
Feet and minute. Yep, feet and minute. So what I want to do first is make a table, because they don't give us a table. I'm going to have feet and minutes. Now, when we go to fill this table out, which one are we going to put the numbers in first? Are we going to put feet first, or are we going to start to put minutes first? Alex?
Feet.
So what are you going to put for feet?
6.
Okay, so normally you do like 1, 2, 3, 4, right? So if we're going to do 1, 2, 3, 4, where should we write that first? Minutes. So let's do that first. Okay, so 1, 2, 3, 4 minutes. So since I did that, I can decide how many, I can change how many minutes. Minutes is going to be X, and feet is going to be Y. Because think about it, doesn't the number of feet depend on minutes? It depends on how long we're going. So y is dependent on x. Feet depends on minutes. So in 1 minute, we've gone 6 feet. 2 minutes, we've gone 12. 3, 18. And 4, 24. So notice, if we can decide what's x and what's y, we've got our coordinates. Remember, in a coordinate, x comes first. So I'm just going to, you don't have to do this all the time, but we're going to have 1, 6, 2, 12, 3, 18, and 4, 24. Those are our 4 coordinates we're going to be graphing today. And then, this is extremely important. If the x and y axis is not labeled, you have to label it yourself. So there is nothing on the x-axis, but we said x is what? What did we say x was? Minutes. So write minutes under the x-axis, if you have room. And we said the y-axis, or y, is feet. So write feet by the y-axis. Now we can plot our points. So hopefully we've got 24 spots. So another important thing, this point right here, look up here. What is this? It's the origin. What's the origin's coordinates? 0, 0. This is 0. So 1 is right here. A big mistake I see is students put 1 at the origin. 1, 2, 3, 4, 5, but it's 1 starts right here, and 1 starts right here as well. Okay? So make sure that you don't put 1 at the origin. So in 1 minute, we're going to go up 6 feet. 2 minutes, we'll go up 12. Doesn't have 24? All right, we can at least get to 3:18. So we're at 3:18 right there. And the reason why you've got a ruler is because what's one of the criteria for proportional? What type of line does it have to be? A straight line. This will help you draw a straight line. If you put the ruler down and it's not going to be straight, then don't try to force it. It might not be proportional. But for this should be a straight line. And it should go through the origin. It should go through the point 0, 0. So since it's straight and goes through the origin, we would say this is proportional. And then make sure that we also explain it's proportional because since we graphed it, let's use the graphing criteria. It makes a straight line that goes through the origin. And if it's not a straight line, it'll be maybe crooked, or it might be a straight line, but it doesn't go through the point 0, 0. Most of the time, you'll be able to see if it's not proportional. Last thing, one way that we can also check to make sure we graphed it correctly, when you simplify all of these, what do you get? 6 or 6 over 1. So should it be proportional? Yeah, because all these unit rates are going to be 6. And so that's one way you can check to make sure the unit rates give you the same thing. All right. So let's look at a couple more. Make sure we've got this down. So they give us the cost of renting video games. So we don't have to make the table this time, but we do need to decide what is X and what is Y. Which one can you choose? How much the cost is, or how many games you buy? How many games? So the one that I can choose is the X value, number of games. And remember I said cost or money? It's almost always the Y value. And cost is going to be Y. Cost depends on how many games you buy. So then don't forget, label your X and Y axis. X is number of games. And then the Y axis would be the cost or the money. And then you can plot your points. 1, 3, 2, 5, 3, 7, and 4, 9. So you can go ahead and plot those. And then once you do that, use your ruler, connect those lines, and see if it gets you a straight line that goes through the origin. Okay, so is it a straight line? It's a straight line. Does it go through the point 0, 0?
No.
It does not. It goes through about at 1, where the y-axis is on 1. So is a straight line, but it does not go through the origin. So we would say this is not proportional. And the reason why it's not proportional is because it does not go through the origin. One thing about when you explain, I think we talked about it a little bit last week. If it asks you to graph, your explanation should go with graphing. So it should be about it's a straight line that goes through the origin. If you did not graph the relationship, your explanation should not be because it's a straight line that goes through the origin. Because you didn't graph it, you don't know if that's the case. So if they ask you to graph, your explanation should be something about what we're talking today. If it doesn't tell you to graph it and you don't graph the relationship, use the same unit rates or the constant ratios. Okay? Any questions so far about this? Do another one together. All right, so let's look at the next one. Once again, they give us the table, number of minutes and number of calories. So which one do you think is X? Which one is independent of the other? Which one is independent? Number of minutes? Yep, number of minutes is independent. Because we would fill out 0, 1, 2, 3 first, and then we would see what calories are. And so minutes is going to go on the x-axis. Calories would go on the y. Then we graph our 4 points. First of all, do we know already something about this? Look at one of those points.
0, 0.
Yeah, so is it going to go through the origin? So now we've got to see if it's going to be a straight line. So graph those 4 points. Now because the graph is smaller, it might be hard to see. So if you have a hard time seeing if this is a straight line, look at your table. Are these always going to get you the same ratios?
No.
This is 1 to 4. This simplifies to get 1 to 4. Is this going to simplify to get 1 to 4? So is it going to be proportional? No. And the reason why we would say it's not proportional and it's not going to make a straight line So it might be easier to see on your paper than up here on the graph, but that 313 makes it a little bit crooked, and so it's not proportional, the line is not straight. Not proportional because the line is not straight. Okay, so decide what x and y are, find your points, label the x and y axis, graph it, and see if it's proportional. You all go ahead and do the last one. So you'll need to come up with the points on your own, and then graph that and see if it's proportional. Okay, so we got hours and money. Which one is x? Which one's going to be x? Money is x. So x is the one that's independent. It doesn't depend on the other. Or it's the one that you would fill out 1, 2, 3, and 4 first. So hours is in, because you can decide how many hours you get, right? But not how much. The money is always 5 an hour. So hours is going to be x, and money will be y. So we label our x and y axis. And then we plot these points. So 1, 5. 2, 10. 3, 15. And 4, 20. So, does it make a straight line? Does it go through the origin? So is it proportional? Yes, it is. Proportional because it makes a straight line that goes through the origin. And once again, to check, you can see that all of these are going to get you the same unit rate, 5/1. Any questions? All right, so one last thing. We got one more question that I can't really do on here, but take your book out, go to page 48, and look at number 2. It's another type of question that we're going to see. So page 48, look at number 2. people at home. For the people at home, so they can see it.
Say if we look at that for a couple minutes and get the problem down. So,
Just in case they don't have their books.
that's it.
Huh?
That's it.
Oh, they already heard you get roasted earlier.
Well, it wasn't even that good. I mean, yours.
I'll come look at it here in a second. All right, so number 2 there on page 48. You look at those two lines and tell me which one is proportional and which one is not. So which one would be proportional? The Book Palace or Discount Books? Why the Book Palace? It makes a straight line that goes through the origin. So sometimes you might have to graph more than one on the same graph, and you compare them to see which one is proportional or not. So that Book Palace makes a straight line that goes through the origin. The other one goes through the origin, but it's not a straight line. And so that's what the explanation you would give. Right, so any questions on how we decide using a graph if something is proportional? All right, so what are the 3 reasons something would be proportional? Give me one, Chris.
Constant rate.
Constant ratios. What's another reason? Fiona?
A straight line through the origin.
Graph makes a straight line that goes through the origin. And then the 3rd reason is, Vincent?
Unit rate.
Same unit rates. Yes, same unit rates. All right, so you guys can start working on these. Get your books out already.